Right, children? Now we are going to derive the law of conservation of momentum derivation. Right, for that we should consider two objects having masses m1 and m2 are traveling with different velocities of u1 and u2 respectively. Here respectively means consequently means one by one. Right, it means the velocity of first object is u1 and the second object is u2. Right, both objects are moving in same direction along a linear path. Okay, it means these two objects which are having masses m1 grams and m2 grams are moving in the same line. Okay, right, linear path means straight line, or inward in Telugu we can call it as సరళ రేఖా మార్గములో ఒకే దిశలో ప్రయాణిస్తున్నటువంటి రెండు వస్తువులని అర్థం చేసుకోవాలి మనం. రైట్, ఇఫ్ the velocity of the first object is greater than the velocity of the second object. Okay, it means if u1 is greater than u2, they collide each other. Collide means అవి ఢీకొంటాయి. They met each other and the collision takes place between them, and the collision takes place between them for a period of time t seconds, for a period of time t seconds, which is very small. T means time period. The time period, the collision time period is very small, means it may equals to 1 second or 2 seconds or at last 5 seconds. Okay, right, consider the time period as very less. Right, so all of you see the screen carefully. Okay, here we have a diagram which shows or which helpful to us to understand the law of conservation of momentum. Okay, now right, I will explain about that diagram later. Just now try to understand about that diagram. Right, when the collision takes place between these two objects, when the collision takes place between these two objects, okay now, it means in shortcut we can call it as during the collision. Okay, what will happen during the collision? An interaction will be takes place between these two objects. At that time we know, according to Newton's third law, what will occur between two objects. Okay, just remind the Newton's third law. What is it? Okay, right, according to the Newton's third law, the first object exerts a force. Exert means applies. The first object exerts a force on the second object. Okay now, right, when it exerts force during the collision. Okay now, right, the first object exerts on the second object. The first object exerts a force on the second object. Here we consider it as F21. Here we consider as F21. F21 means force on second object. Force on second object by the first one. By the first one. First one means first object. Okay now, right, to understand more about it, just go through the diagram. So see the diagram before the collision. Okay now, the size of the first object is m1, the mass of the first object is m1, the mass of the second object is m2, the velocity of the first object is u1, the velocity of the second object is u2 before collision. During the collision, what will happen? Listen here carefully, see the screen carefully. During the collision, okay now, right, two occur collision between these two objects, we considered as velocity of the first object. Velocity of the first object, how much? u1 is greater than the velocity of the second object. Already we know the velocity of second object, that is u2. Okay na? Between these two velocities, u1 is greater than u2, means m1 ఆబ్జెక్ట్ m1 ఫస్ట్ ఆబ్జెక్ట్ యొక్క వెలాసిటీ ఎక్కువ, దేనికంటే సెకండ్ ఆబ్జెక్ట్ యొక్క వెలాసిటీ ఎక్కువ. అంటే ఇది ఎక్కువ స్పీడ్గా వస్తూ ఉంటుంది, ఇది తక్కువ స్పీడ్తో పోతూ ఉంటుంది. ఎట్ దట్ టైమ్ దేర్ మే బీ సమ్ చాయిస్ టు హ్యాపెన్ collision between these two objects. So after a period of time, after few seconds, a collision will be takes place between these two objects. During that collision, what will happen? Now I am explaining. During the collision, what will happen? First object exerts a force on second object. First object exerts a force on second object. That is, we call it as F21. See here carefully. That is, we call it as F21. F21 we call as action force. F21 we call as action force. Right. At that time, simultaneously, according to the Newton's third law, according to the Newton's third law, the second object will also exerts a force on the first one. That is F12. F12 means force on first object by the second. We call it as reaction force. See the diagram carefully. We call it as reaction force. See the diagram carefully. Okay, to more understand, I wrote some important point. See it. Collision taking place between them for the time period of t. Here time period considered as 1 second or 2 seconds or at last 5 seconds. Okay na? Less than 1 minute. Okay, right. So now I am repeating once again. According to during the collision, what will happen? The first object exerts a force on the second object, that is F21. F21 means force on the second by the first one, and the second object exerts the force on the first one, that is F12. F12 means force on the first object by the second object simultaneously. Okay, here keep one thing in your mind. Action force and reaction force both works on one another simultaneously. Okay, we learnt about it in the Newton's third law. Right. Let us consider let's consider v1 and v2. V1 and v2 are the velocities of the both objects respectively after collision. To understand about it, we go through the diagram once again. See the diagram. During the collision, some forces works on each other. First one applying force F21, second one applying force on first one is F12. Okay, now after the collision, what will happen? First object moves along the linear path with the velocity of v1, and the second object moves along the path with the velocity v2. Okay na? Right. This is not in our syllabus, but one thing you keep in your mind, that is after collision v1 is less than v2. Means the velocity of the first object is less than the velocity of the second object. Okay na? Keep this thing in your mind. Okay, it may help to you in your higher classes. Okay na? Right. So just now I am reminding once again. Let's consider v1 and v2 are the velocities of the two objects respectively after collision. Right. Okay. Right, Nana. Already we learnt about momentum. In the last class. Okay. According to the definition of momentum, we can say momentum is equals to mass and velocity of the object. And also we studied in the topic, momentum is named as mass in motion. It is the property of moving objects. Okay, right. According to the definition of momentum from the diagram, we can write like that. Okay, so all of you see the screen carefully. That is, before collision, what will happen? Before we are calculating the momentum of the each and every object. Okay, na? That is case. In which case we are calculating momentum? Before collision. So all of you see here, right? Momentum of first object. Already we know the mass of the first object and velocity of it. How much it is? How much it is? Right. So from the diagram we can write it as momentum of first object is equals to mass into velocity. It is equals to m1 into u1. Okay, na? Consider it as equation number 1. Right. In the same way, momentum of second object. Similarly, here just I wrote as similarly. In the same way means similarly means same. Right. Similarly, momentum of second object. In which case? Before collision case, momentum of second object is also equals to m2 u2. Just you go through the diagram. Here before collision, mass of the first object is m1, velocity u1. So momentum of first object equals to m1 u1. Momentum of second object is equals to m2 u2. Okay, right. From the figure, now we are calculating the momentum of both objects after collision. Right. After collision, how much? Now we are going to calculate it. That is momentum of first object. Momentum indicated with the letter of P. Already here we are calculating the momentum of first object. So I am taking it as P1. Okay. Momentum of first object is equals to mass into velocity. So we can write here as m1 into v1. Consider it as equation number 3. In the same way, momentum of second object P2 is equals to m2 into Vt. Consider it as equation number 4. Right. Now, therefore, now we are going to calculate the change in the momentum of first object. Okay. Why do we calculate change in the momentum here? Why? Because collision takes place between two objects. So some change will occur in its momentum. For that, we are calculating change in the momentum of first object. What is equals to how much it may be? Right. We are going to calculate it. See the screen carefully. Change in the momentum of first object is equals to, already we know change means final behavior, final momentum minus initial momentum. What is the final momentum of first object? That is equals to, final momentum means after collision. Momentum after collision minus momentum before collision. Momentum after collision minus momentum before collision. It is equals to m1 v1 minus m2 u2. Consider this equation as equation number 5. Similarly, change in the momentum of second object. Already we know the momentum of second object. Before collision m2 u2, after collision m2 v2. Now we are going to calculate here changes. So change is equals to what we write here? Final momentum after collision of second object minus momentum before collision. So that is equals to m2 v2 minus m2 u2. Consider it as equation number 6. Okay, therefore rate of change in momentum. Okay, na? Why? Because we are calculating rate of change in momentum. Why? Because collision takes place for a period of time t. So we are going to calculate rate of change in momentum of first object. Okay, right. If the collision takes place more time, rate of change in momentum will also change. So further we are calculating here rate of change in momentum of first object. It is equals to m1 v1 minus m1 u1 by t. Here t means collision takes time, takes period and takes time. Similarly, rate of change in momentum of second object is equals to m2 v2 minus m2 u2 by t. Okay, consider these two equations as equation number 7 and equation number 8. Okay, right. Now we are going to sum up this law of conservation of momentum within few minutes. So see carefully. Right. Already we know that from the Newton's third law. Okay. What is Newton's third law? There will be reaction force. There will be reaction force for every action. There will be a reaction for every action, but equal in magnitude, but opposite in direction. So from that law we are going to write as reaction force is equals to minus action force. Okay, right. Just we considered as reaction force in this topic as F12. Okay, if you have any doubt, you can check your notes or go through your textbook. Here reaction force is F12 is equals to action force is what here? F21. So what we write here? F12 is equals to minus of F21. Okay. In the same way, we learnt about Newton's second law in the previous classes. Okay. From that Newton's second law, we know that rate of change of momentum is proportional to the net force applied on the object. That second law we can write here as in the form of equation as delta p1 by t is equal to minus of delta p2 by t. Why? Because F is proportional to delta p by t from Newton's second law. So here F1 instead of F12 we are writing here delta p1 by t. Instead of F21 we are writing here delta p2 by t. Okay, right. Already we know about delta p1. Delta p1 means here triangle means delta. Delta means change. Delta means change in physics. Okay now, right. Delta p1 means how much? It is equal to m1 v1 minus m1 u1. Okay, so in that fractional numerator, in that fraction you can write numerator as m1 v1 minus m1 u1 by t is equals to minus of m2 v2 minus m2 u2 by t. Here how you have a doubt how our madam write delta p1 is equals to instead of delta p1 is equal to m1 v1 minus m1 u1, delta p2 is equals to m2 v2 minus m2 u2. How it is possible? Just see equation number 5 and 6. Then you can understand very easily. Right. Already we know in mathematics equal symbol lo two fractions denominator similar ga unnai anukondi em chestam, we can cancel it. So here tt cancel. Then we have m1 v1. Then we have what we have? m1 implies m1 v1 minus m1 u1 equal to minus of m2 v2 minus m2 u2. Right, implies we can say right m1 v1 minus m1 u1 equals to minus to ikkada lopaliki multiply chestunnanu. Listen here, see here carefully. Minus into m2 v2 minus m2 v2 minus into minus plus. So instead of minus I am writing here plus. So emaitana minus m2 v2 plus m2 u2. Now I am transposing. Transposing means moving from one side to another side. Now I am transposing minus m2 v2 from RHS to LHS and transposing minus m1 u1 from LHS to RHS. Okay, right. LHS means left hand side to right hand side, right hand side to RHS means right hand side, LHS means left hand side. మైనస్ M2 V2ను RHS నుంచి LHS తీసుకుపోయినాం, మైనస్ M1 U1 LHS నుంచి RHS తీసుకొచ్చినాం. అలా చేయడం వల్ల మనకి ఏమొస్తుంది? వి గెట్ M1 V1 ప్లస్ M2 V2 ఈక్వల్స్ టు M1 U1 ప్లస్ M2 U2. ఇట్ మీన్స్ అంటే దాని అర్థం ఏంటో చూద్దాం. M1 V1 ప్లస్ M2 U2 అంటే ఏంటి? ఇక్కడ V1 అనేది వెలాసిటీస్ ఆఫ్టర్ కొలిజన్ కదా నాన్న, అది ఎవరిది? ఫస్ట్ ఆబ్జెక్ట్, సెకండ్ ఆబ్జెక్ట్. సో ఏమర్థం? వాట్ వీ కెన్ సే, వాట్ వీ కెన్ రైట్ హియర్, total momentum of two objects after collision is equals to total momentum of two objects before collision. Therefore, from the above equation we observe that what we observed here, the total momentum is unchanged. Before and after collision. Hence what we can say? The momentum is conserved. Means ద్రవ్య వేగము, తెలుగులో ద్రవ్య వేగము నిత్యత్వం అయిపోయింది. మొమెంటం కన్జర్వ్ అయిపోయింది. మొమెంటం కన్జర్వ్ అయిపోయిందంటే ఏమైపోతుంది? ఎఫ్ నెట్ ఏమైంది? జీరో అయింది. నెట్ ఫోర్స్ జీరో అయిందంటే ఏంటంటే అక్కడ ఇంటర్నల్గా వాటి యొక్క మొమెంటం చేంజ్ అయింది. కానీ ఫైనల్గా చూసుకుంటే ఏమైపోయింది? మొమెంటంలో ఎటువంటి చేంజ్ లేదు. ఇంతకుముందు ఎంత ఉన్నదో ఇప్పుడు కూడా అంతే ఉంది అన్నట్టు. అర్థమవుతుందా? అంటే ఏమైందండి అక్కడ నెట్ ఫోర్స్ వల్ల ఏమైనా చేంజ్ వచ్చేసిందా? ఏమీ చేంజ్ లేదు. ఆ టూ ఆబ్జెక్ట్స్ ఇంతకుముందు ఉన్నాయి, ఒకదానికి ఎక్కువ ఉండొచ్చు, రెండో దానికి తక్కువ ఉన్నది కావచ్చు. ఆఫ్టర్ కొలిజన్ ఏమైపోయింది? మొదటి దానికి తక్కువైంది, రెండో దానికి పెరిగింది. మొదటి దానికి ఎంతైతే తగ్గిందో రెండో దాన్ని అంతే పెరిగింది. సో వాట్ వీ కెన్ సే హియర్, మొమెంటమ్ ఈజ్ కన్జర్వ్డ్. మీన్స్ ద్రవ్య వేగం, మాస్ ఇన్ మోషన్లో ఇంటర్నల్ చేంజెస్ ఉండొచ్చు, కానీ ఫైనల్గా చూసుకుంటే మాత్రం మాస్ ఇన్ మోషన్ ఏ విధంగా ఉంటుంది? ఈక్వల్గానే ఉంటుంది. అది బిఫోర్ కొలిజన్ ఎంతైతే ఉందో ఆఫ్టర్ కొలిజన్ కూడా అంతే ఉంది. సో వీ కెన్ సే మొమెంటమ్ ఈజ్ as conserved. Okay, right, keep this thing in your mind. This is enough for today. Thank you.